All right, this is what we're going to do. We're going to talk about RQLite. If you're ever curious about RQLite or SQLite, it is a relational database. And in fact, as we're going to learn about it right now, it is the world's largest, most widely used database because it's an embedded database. And that means that it can work basically anywhere in any application. They made it really easy to embed it directly into your application. So even mobile apps can come distributed with it. Web browsers, Chrome, Microsoft Edge, the Opera, Mozilla, they all have built-in SQLite. Even games have this. It turns out it is the most widely used database for this reason, and everyone on the planet has used SQLite. There is a problem with SQLite if you want to use it the way you would, like, say, MySQL or Postgres. These databases have administrivia baked into them by default. SQLite is just an embedded database. It lets you access either an in-memory database or you can access a file on disk, and it is super fast. You would think, oh, there's no way it could outperform MySQL or Postgres. It actually keeps on par and can defeat in terms of performance these other databases. Here's the problem though. SQLite, it doesn't come with that administrivia capability. It doesn't have users or permissions or roles. These other databases have those kinds of administrivia. SQLite doesn't. For example, RQLite brings with it one of the benefits that you get from MySQL or Postgres, and that is distributed capabilities, which allows you to easily, what do you do with databases? You want to have more than one for fault tolerance and scalability, and that is what RQLite allows. I like my databases fault tolerant, please, with high availability and zero hassle. Well, almost zero hassle. I was looking through it. It's near zero. They do a pretty good job. It's a pretty good job. You just have to collect a few things. And also I have we're going to talk about a thing eventually here that I dislike. It's their algorithm that they use for the fault tolerance and distributed capabilities, because I've seen significant failures in this approach. Good news is, though, it seems like we've figured out the algorithm. It's 2024, so let's dive in. Let's see what else we got here. Actually, let's just walk through what is RQLite. It's quick, little, easy. RQLite is a distributed relational database that combines the simplicity of SQLite. No, it's more than that. They just take, okay, here's SQLite. Now let's make it distributed. We'll be able to throw it on all these servers. They add an HTTP endpoint, which is my favorite thing. So now you can make HTTP calls to the RQLite HTTP server, which is running SQLite underneath, and allows you to query your database or insert into it using HTTP, which is amazing. I really like that. You also have, of course, our traditional mechanism for connecting. The good news is they add a robustness of fault-tolerant, highly available system using the Raft algorithm. It's developer-friendly, its operations straightforward, and designed for reliability with minimal complexity. I agree with this statement. The minimal complexity, it manages it. Yeah. So if you're a DevOps engineer and you want to manage RQLite, you'll have a good time because it's really easy. This zero hassle. There's some hassle. There's a little bit of hassle, but minimal complexity. Sure, yeah, that counts. It does deploy in seconds. There's no complex configurations. It's all CLI driven, which is fantastic. They have the HTTP API. I love this. This is so good. This is amazing. I like this part. This makes it very easy for app developers. Seamlessly integrates with modern cloud infrastructure. They bring extra. It comes with extra. So it comes with a Docker container, a Helm chart for Kubernetes, and a few extras. They do a really good job. It's built on SQLite. Well, it is SQLite. They just take SQLite and then they put operations capabilities on it. It is the world's most popular database because of the fact that it is the most widely used. It supports everything that the major databases support. Did you know? Full text search, vector search, the new fancy vector search, and JSON documents. See, it's got everything you need, basically. Oh wait, no way. It has access control? I thought it only brought with it the distributed capability. Oh wow, so this basically turns SQLite into, MySQL and a Postgres, and it does it in a much better, easier way. And encryption for secure deployments. Interesting. That goes above and beyond what I was expecting. That's amazing. Yeah, reliable, rigorous automation testing, clustering provides high availability, and automatic node discovery through the Raft protocol, which is one of the nice features of Raft. And that's it. Where we go. One of the promises of RQLite is that it was really easy, almost minimal complexity. They say 0 effort, though there's a little bit of effort in there in order to get up and running quickly. Let's see how well they make it. How easy do they make it? They say it's the quickest and easiest way to get running is to download the pre-built binary releases on GitHub on the release page. I actually am kind of curious just to check this out. What do they have here? Okay, so they've got your Docker, they've got your Linux, so you can just copy and paste that command. Brew install RQLite, and then they have RQLite can be built on Windows, and Windows compatibility ensures app voyeur. You can download a pre-built release for download, and here's a list of Windows. So that's actually really great because it allows you to run on Windows if that's your development environment as well. Typically, you're going to run this on a Linux/Unix system, Linux obviously, where you're going to be running the actual RQLite database and a distributed cluster. They make it really easy. I like that you don't even have to run this command, this top first command. You just have to run this command right here. Docker run the port. This is going to be here. Let me zoom in so you can see it. Let's actually make it a little bit easier for you to see. You just copy this command right here, and you're going to be running the Docker container for RQLite, and it starts an HTTP server. And this just says opens port between the host and the container itself, and this will be the HTTP port that is the default port to make essentially API calls into your RQLite database to select data, insert data, update data, and delete data all through the API. And so if you're running on Linux and Windows and Mac, you run the RQLite D for daemon, which is the runtime. It's essentially the server that brings with it two things by default extra: the HTTP server itself, the underlying SQLite database, which then is interfaced through the HTTP interface, and the Raft protocol, which allows you to cluster the RQLite. And this gives you the ability to read and write to that data. And look, look, no configuration files. It's just command line only, and they make it really easy. I like Docker. And here is the Docker command. You say Docker run the port and then RQLite. And so that's what I'm going to do here really quick. Let's give that a shot. All right, I've got my terminal window open here. I already had boom, easy. I now have running essentially a SQLite database that has an HTTP endpoint. And also there is a Raft endpoint in here somewhere. And all the defaults. Warning, timeout reached, starting, electing last leader. So myself is now the leader. Yeah, okay. So this is the Raft protocol output that I'm seeing. Oh yeah, it even says Raft right here. That's kind of nice. So there we go. RQLite daemon, bootstrapping, single node, HTTP endpoint available. This is so cool. All right, for testing purposes, let's go through really quick to see if we've got everything up. So I started my Docker container that's running on localhost port 4001. There is a RQLite shell, which makes it really easy for you to just directly interact using standard SQL. So let's create a table. Let's just make sure it works. So we're going to create a table. I'm going to copy this here, and we're going to put that into our terminal window. Oh, no. Let's do RQLite. RQLite. There we go. Ready to go. Let's create a table. Perfect. That part's good. Okay. Wait. Oh, let's actually check this out. Let's actually test this here. So let's visit .schema. Very nice. So that tells you what the current table is, schema. Let's insert into the table. We will have a foo, which is going to be, that's the table. And then we have an ID, integer, primary, not null, primary key, and then a name. So we should be able to insert this. Well, and the ID must auto increment by default. Oh, it's a primary key. So I only have to insert into foo the name for value Fiona. Let's give it a try. Let's see if that works. Okay. Yep. Then we should be able to say select star from, and our table name is foo. I should work. Perfect. We've got one Fiona. Can we have two Fionas? All right. Let's try it again. Yeah, we do. We have two Fionas, and it auto increments. All right. So that's very nice. So if we got this far, that means you're set up. Wasn't that easy? That was the easiest possible setup. I love it. Zero configuration, and you can't really configure it much further because you don't really need to. They did say there are permissions and additional security features built in, and there's auto clustering capabilities. which we can do also here through RQLite daemon by specifying the node ID. You've got your HTTP port, which you don't need to worry about if you're running on multiple machines, which is what you're going to want to do. You don't want to run this all on your same machine. Well, it's strictly not necessary to run RQLite. It's not strictly necessary to run RQLite. Running multiple nodes means you'll have a fault-tolerant cluster. Yes, okay. You don't need to do a cluster. You want to do a cluster. That's what you definitely want to. It makes your life better because one of the nodes can fail, and this happens all the time. Hardware fails. You have to expect it to fail. A cable can get unplugged. The power can go out temporarily. A hardware component can fail, preventing successful operations. So you need to start 2 or more nodes, and you can do by specifying the node ID and the HTTP port. You don't need that because this is just an example running on the same machine. And then your raft address, which is also you don't need to specify if you're running on a different machine. Because the raft port will just be automatic. It's automatic. And then you say which node you're going to join. So we're going to be joining our original node, it looks like. And then it looks like you can label, give a name to what the server is going to be. So you call it data 2, data 3, or MySQLite database 2, or my RQLite database 3, for example. And it says this demonstration shows all 3 nodes running on the same host. That's right. In reality, you probably don't want to do this, obviously, because now there's no point. You're wasting time here. And then you wouldn't need to select different HTTP. Okay. So yeah, it's actually saying yes. So these 2 features here, the HTTP port address and raft address, you never need to specify those when you're running on different machines because there's default ports and you don't need to have dedicated ports. You do, though, on the same machine because if you bring up more than one daemon on a machine and they try to access the same port, you'll get access denied. The operating system will say, this port has already been bound to another process. So that's why you need to do that here. You don't need to do that when you're running on dedicated cluster machines. So yes is the answer to the question. They made it easy. Yes. Now that we have a distributed RQLite database, a cluster that's spread across a whole bunch of servers, will show how a developer can access this data. You'll probably want to set up a DNS record that has a records that points directly to all of the nodes that are available to you. If you're running in Kubernetes, of course, you can have a service that does this, or kubedns. If you're managing it manually, you can have an API that updates and appends a records into the list so that way your client can connect to one of the randomly selected IP addresses, which you want round robin in that case. You could also have, there's a whole bunch of ways that you can do this. You basically, let's just show the easy part. How do I read data, write data, delete data, and update data? First, really straightforward. This is my favorite part about RQLite. It comes with a built-in HTTP server on top. So now it makes accessing all of the database features and from a data perspective really easy. You can do it through curl. Look at this, through a simple post. So we're going to try this out. We're going to do this right now. This is what we're going to do. Okay, we are going to start up our database, and then we're going to run this curl command, and then we're going to see that we've created a table. So this is what it's going to do. I'm going to start up a database on my local host. I'm going to use Docker. The default port for HTTP is going to be 4001. Then I'm going to execute this path. And remember, there's some other paths up here. So we can execute, we can query, and then we can request. Wait. Stop. Hold on. This execute, which accepts insert, update, and delete. Okay, so these are mutations. And then query, which accepts select. And then you can do request, which does both. This endpoint is known as a unified endpoint. Okay, so perhaps if you wanted to help segment how your application is working and you want to ensure that you're not doing any accidents, this could be just a nice little cautionary endpoint. So you'd run all of your queries through this path. So you'd say /db/query, and then you'd be able to run a select statement. But if you try to run an insert statement or any mutation statement, it'll block it. So you've got your read-only and then your write-only endpoints. That can be helpful to help segment the different parts of your application. It helps reduce accidents. So I kind of like that. I do like that this is a universal endpoint to make it easy. This is really cool. wait, which endpoint should I use? If you know ahead of time whether you are doing reads or writes, it's probably best to choose the endpoint dedicated to that type of request. I mean, you don't really have a choice. If you choose the wrong one, it won't let you. So you have to pick the other one, either execute or query. As you will know precisely what to expect when RQLite responds. This encourages the most robust interaction with RQLite. In contrast, the structure of the response from RQLite requests will depend on whether you send data or send reads or write requests. That means that you may require your code to inspect the response. Okay, so that's actually also interesting because the response between execute and query is going to have a different JSON format. So your application is going to be able to detect that. If you are using RQLite, can be more convenient in some cases as you don't need to worry about choosing a particular endpoint ahead of time. You do, however, need to know how to parse the response. If you're reading data or writing data, it looks like it might return different kinds of response types. So let's try writing data. Let's try this. I'm going to copy and paste this. So first what we're going to do is we're going to start up our database. And I like Docker, so we're going to be running Docker. Boom, up and running. Database up and running. Then we copied our, let's copy this really quick. And then we'll go back to our database. All right, here we go. So now I should be able to just run this command. Here we go. I'm pretty sure this will work. Maybe. No, because it's on multi-line and my terminal is not happy about it. Give me 1 second. Because they added line breaks here, it causes an issue with my terminal, and probably yours too. So you'll want to make sure if you copy and paste this, it needs to be all in one line before you insert it into your terminal. So let's go ahead and put that into my terminal here. And all in one line, boom. Immediate, amazing. Execute. Perfect. So look at the results, the time. It just says it worked. That's all I get. That's all the information. So I probably got a HTTP 200 on that. Now let's see what else we should be able to query. So this was the execution path. It also returned as pretty. Oh, and we requested for timings. That is kind of neat. Okay, so what else we have? Now let's insert some data. We'll do this really quick. We'll insert some data. Here we go, inserting some data. Results, last insert ID, rows affected, and time. So we've got, so basically I'm reading this as success. Obviously you can check the status code. Woo, you know what? Let's do that. Let's see what the status code is. So let's do a V. So we get, I'm guessing at 200, okay. Yep, here we go. So we got HP 1.1, 200, okay. Perfect, that is awesome. And then since I inserted twice, I have another ID and one row affected. And in case you were looking at the time, this is going to probably be seconds. And then we've got milliseconds. Oh, and now we're into the microseconds. So the time it took to insert that data was less than half a millisecond. That's amazing. We're in the future. It goes so fast these days. And this is probably the total time round trip between sending the data being request being received by the RQLite HB server, running through the process, and then responding. So that looks like that took 3.6 milliseconds. Oh, interesting response form. So it does show you a response here. For whatever reason, I'm getting on my laptop much better timings, like much better performance. SQLite, I mean, they probably wrote this doc in an older version of SQLite, and they've made amazing improvements with SQLite. Also newer hardware, though this machine's pretty old. It's like 6 years old-ish. Let's see, the use of the URL param pretty is optional, and it nicely formats my JSON for me. And you also have timings, which includes time telemetry, if you like that, which I do. Let's query the data. So now we're going to use the path /db/query, pretty and timings, and then we're going to select everything from the foo table. So let's go ahead and copy that. Copy. And I should get a response that looks like this. Let's see if we do. Let's see if we get the same response. All right, here we go. Oh, I didn't copy everything. 1 second. All right, so curl. Okay, there we go. Boom. All right, so we got results. We got some columns. We got data types, and we got the values. Oh, nice. Okay, I see. That makes a lot of sense. So to compact the response, you don't always want to have dictionaries. So your values are going to be an ordered list, based on the types that you get up here from the columns and the types. So it's a good efficient return type that's still very easy. So then from the client side perspective, or the receiving application that made the call, you can restructure this in a way that you understand. This is going to be the ID, this will be the name, and this will be the age of the user. Oh, look at this. They also let you query via the post request, which is kind of nice. All right, let's give that a shot. We'll also copy paste this and put that into our terminal window as well. Jump over here. And then boom. Yep, there we go. Same output, same result. Just using post instead of what was capital G. What we were doing with this curl-G. What does the G flag do in curl? I'm kind of curious. I'm gonna take a look at that really quick. All right, G. Oh, of course. You don't need to specify -G. So this is a within the HTTP world and REST APIs. You've got HTTP methods. These methods are like get, post, put, patch, delete. A lot of methods. They're also called HTTP verbs. By default, when you're using curl, every HTTP call is going to be an HTTP GET request. So you don't even need to specify -G. You don't need to. It's just the default. What you do need to do is make sure that you're specifying any kind of other HTTP method. That's why I was confused. Like, what is this -G? You don't need it, right? Well, actually, let's find out. Let's actually try it. Let's double check. All right, there, we're getting rid of the G. Invalid JSON body. Oh, what? Hold on. Oh, it's because we're doing something bogus. I get it. All right, this is why they specify -G. By default, the data URL encoding and the -G, this is going to attempt to make a post call, isn't it? So without the -G, it's going to make a post call. So 400 bad request. Does it say what I'm trying to do? Yep, there it is. It's trying to make a post, and it's doing the post because I've included this here. So by specifying -G, we are saying I explicitly intend to break the protocol of the HTTP specification because we're not supposed to have any data in the payload of the body for a GET request. You can force it, though, if you put -G. That makes a lot more sense. So now we can say -G and it works. That is crazy. Let's look at the verbose output here. Let's see. I want to double check. So yep, you're getting data. That is so crazy. Oh, okay. And then it puts it into URL parameters. So now we are not okay. I get it. Okay. We are not breaking the spec. We're just saying data URL encode. Instead of putting it into the body through a post, we're going to put it into the URL as query parameters, essentially. So Q and then our query itself. That's fair. Okay, I get it now. That's what's happening. And that's what the -G does. Okay, here we go. We were just talking about this. Check this out. We can have an associated response form by adding an extra query parameter and associative, and it gives us a nice result output. So before we had data types and the column names. Instead, with associative, it gives us rows as dictionaries rather than arrays. So you saw here, so we get arrays output. So this is the non-associative, and then you get a whole bunch of values. This is going to be better if you're going to get a bunch of values because there's less network transmission. So there's less data to transmit and less work for the RQLite server. It's more scalable. You'd probably want to keep this approach if you're anticipating a larger scale. From a cost perspective, this is cheaper. From a simplicity perspective, this is very nice. I like this. This is easier for application developers. So just add and associative to your URL when you're querying data. So that way you get a dictionary back rather than an array that looks like this. So it's just nicer from that perspective. It's easier to deal with. And of course, to avoid SQL injection attacks, we want to make sure that we are taking advantage of parameterized statements that prevents escaping SQL. For example, an attacker could have a name that has some backslashes and some other escape characters that would cause issues for your database. Essentially, they get full control of your database at that point. They could delete data. They can read any kind of data that they want. To prevent that, use parameterized statements with these question mark settings here, or well, question mark characters. Instead of directly putting values into your insert statement, you're going to use question marks. And then a second parameter is going to provide the actual data itself. And what the RQLite HTTP server is going to do is ensure that this data is clean and this data is clean before it runs the statement. This allows you a level of security that prevents SQL injection attacks. So definitely always good practice to use parameterized statements in any kind of case. You can also use name statements, so that way your question marks, instead of being question marks, they become names. This is easier to read. I do like this, and since usually databases you're going to have a higher read than write ratio, it's better to use this approach just from a maintainability perspective. So this is kind of nice. So here's your name, here's your age, and then you just pass in dictionaries for the insertion statements.